Hi students, good evening to everyone. So today we are going to discuss chemical bonding. So what is a chemical bonding and what are the types of chemical bonds and what are the theorems that we are going to discuss in this chapter. So first, chemical bonding. So by early of 19th century, by late of 19th century and early of 20th century, scientists know the only three types of forces. So in that gravitational, magnetic, electrostatic forces only they know. So based on that, they thought that by the formation of the molecules and compounds only the electrostatic forces are the relatable to the formation of the bonds. So in the bond formation, the every atom having the electrons and protons. So electrons are the responsible for the bond formation, that is taken by the scientist actually first. So how it is, they imagine that formation of the bonds between the two atoms. So for example, you have to take the A atom. For example, you have to take the A atom and B atom. So in this A atom nucleus, in the B atom of electron, it is attracted towards the A atom of nucleus. In the B atom nucleus can attract the A atom electron. Means opposite nucleus can attract the opposite atom of electrons. There we can say as the electrostatic attractions this is. So they thought that there is an attraction between the two atoms when it is closer. When it is a closer, there is an attraction may be formed between the two atoms. So they can call this is a bond formed between the two atoms. Right. So there is a one question. Water molecular formula is H2O. Why can't we write as a HO2? So bond formation outunnayi. So they are forming some formulas. So how should we write the formulas? For that, this is a question. So molecular formula of water is only H2O. Why should we write? Why not we can write as a HO2? So reason is based on the valency electrons. Based on the valency electrons, we have to write the molecular formulas. So that only I wrote here. Due to the valency of hydrogen atom and oxygen atom. Hydrogen is belongs to the first A group element. Hydrogen is belongs to the first A group element. Oxygen is belongs to the sixth A group element. So oxygen is required the 2 electrons. So valence is 2. Hydrogen is the first A group element. So its valence is 1. So based on the crisscross method, that valences we have to write into the opposite bases. So based on that we can write H is a 1. So we can write the oxygen is 1. Oxygen valence is 2. So we can write the hydrogen 2. So this is the molecular formula of water as H2O. Right. So chemical bond, రసాయన బంధం. సో రసాయన బంధం గురించి ఈ చాప్టర్ లో నేర్చుకుంటాం. సో ఇక్కడ మొదటగా సైంటిస్టులకు గ్రావిటేషనల్, ఎలక్ట్రోస్టాటిక్ అండ్ మ్యాగ్నెటిక్ ఫోర్సెస్ గురించి మాత్రమే తెలుసు. సో అక్కడ తెలిసినటువంటి ఆ ఎలక్ట్రోస్టాటిక్ ఫోర్స్ ఎలా ఉంటుంది అనుకున్నారంటే, రెండు ఆటమ్స్ క్లోజర్ గా వచ్చినప్పుడు ఇక్కడ ఉన్నటువంటి కేంద్రకం, ఏ ఆటమ్ లో ఉన్నటువంటి కేంద్రకము బి ఆటమ్ లో ఉన్నటువంటి ఎలక్ట్రాన్ ని ఆకర్షించడం వల్ల అక్కడ ఒక ఫోర్స్ అనేటువంటిది జనరేట్ అవుతుంది. అలాగే బి ఆటమ్ లో ఉన్నటువంటి కేంద్రకము ఏ ఆటమ్ లో ఉన్నటువంటి ఎలక్ట్రాన్ ని ఆకర్షించడం వల్ల అక్కడ ఒక ఫోర్స్ అనేటువంటిది జనరేట్ అవుతుంది. ఆ ఫోర్స్ ని వాళ్ళు ఎలక్ట్రోస్టాటిక్ ఫోర్స్ అనేటువంటిది అన్నారు. సో దానివల్ల ఆ రెండు ఆటమ్స్ అనేటువంటిది ఒక బాండ్ ఫార్మేషన్ అయ్యాయి అనేటువంటిది చెప్పడం జరిగింది. దాన్ని మనం ఎలా పేరు పెట్టి పిలిచామో రసాయన బంధం అనేటువంటిది చెప్పడం జరిగింది. ఇక్కడ వాటర్ కి సంబంధించినటువంటి అణు ఫార్ములాని H2O గానే రాస్తాం. ఎందుకు HO2 గా రాయము అంటే వాటికి సంబంధించినటువంటి కర్పర విన్యాసం ఎలా ఉంటుంది అనేటువంటి దాన్ని బేస్ చేసుకుని మనం దాని యొక్క వాలెన్సీని ఆధారంగా చేసుకుని హైడ్రోజన్ వాలెన్సీ 1, ఆక్సిజన్ వాలెన్సీ 2 కాబట్టి వీటిని క్రిస్ క్రాస్ మెథడ్ ఉపయోగించి దాని యొక్క మాలిక్యులర్ ఫార్ములాని H2O గా రాస్తాం. ఈ మెథడ్ ద్వారా ప్రతి ఒక్క మాలిక్యులర్ ఫార్ములాని మనం అప్లై చేయవచ్చు. సో నెక్స్ట్, Lewis symbols or Lewis dot structures means elements or atoms are involving into the bond formations. So how it will be involved? So for that explanation, first attempt by the Lewis. So he was explained the atom having the valence electrons as well as inner electrons, inner shell electrons and valence electrons. Only valence electrons only responsible for the formation of the bond. So he was classified that symbol, element symbol and the inner electrons can be shown as a symbol of element. And what are the valence electrons? Every atom having the valence electrons in the outermost shell, so that all the electrons can be denoted as a dot structures or a cross marks. అంటే చుక్కలు లేదా గుణకారపు గుర్తులతో వాలెన్స్ షెల్ లో ఉన్నటువంటి ఎలక్ట్రాన్స్ ని డినోట్ చేస్తారు. So what is the definition of the Lewis dot structure? The valence electrons in the atom elements are depicted in a short form by the Lewis symbols. Examples ni chudandi. So for example, you can take the hydrogen. So hydrogen atomic number vachesi 1. So its a configuration is 1s1. So it is having only one electron in the valence shell. So it can be denoted as hydrogen. Then that one electron we can show as a dot. This is the hydrogen atom Lewis dot structure. For example, you can take the lithium. You can take the lithium. So its atomic number is 3. Configuration is 1s2, 2s1. So in this first shell and second shell. So what is the valence shell here? Second shell is the valence shell. So in this second shell, how many valence electrons it is? Only one electron is there. So that we can denote as a lithium, and it is having only one single electron in the valence shell. For example, you can take the boron. What is the atomic number here? 5. So boron atomic number is 5. Electronic configuration. So 1s2, 2s2, 2p1. So here the valence shell is a second shell, and it is having 3 valence electrons. So these all the 3 valence electron can be denoted as, so boron. So 3 electrons, 3 dots we can show in each direction of 1 electron. In the direction of each direction is 1 electron. For example, you can take the carbon. 1s2, 2s2, 2p2. So it is having 4 electrons. It is having 4 electrons. So it can be denoted as, so carbon we can take. So it is having the 4 valence electrons. That all the valence electrons can be denoted as 1, 2, 3, 4. So this is a representation of the Lewis dot structure. You can take the nitrogen. So its atomic number is 7. So 1s2, 2s2, 2p3. So it is having 5 valence electrons. There is a doubt. So if it is a 5 valence electrons, how we can represent it? How we can represent the 5 valence electrons? So how he was explained that 5 electrons, how we can represent means, first you have to take the 1 electron in the one side. So 1 electron in the one side. Then you have to start the pair of the electrons. You have to start the pair of the electrons. Means up to the 4 electrons, we have to denote as a 1 electron in the each direction. If it is a more than 4 electrons, first you have to fill the single electrons. Then you can start the pair of electrons. You can check with oxygen. Oxygen atomic number is 8. So electronic configuration 1s2, 2s2, 2p4. So here the total valence electrons is 6. So we can represent as, so oxygen. Totally how to denote the valence electrons number is 6. So we can represent, first you have to fill the each direction is 1 electron. So total 4 is completed. So still it is a 2 electrons is there. So you have to start the pair of the electrons. Means oxygen atom having the 2 pair of electrons and 2 single electrons. So these 2 single electrons can involve in the bond formation. For the nitrogen atom, 1 pair of electron, 3 single electrons is there. So these 3 single electrons are the responsible for the bond formation. In the carbon, there is all 4 single electrons. So it can involve in 4 bond formations. Like that, it was explained. Okay, check with the noble gases. Noble gases is helium, neon, argon. So these three we have to check. So what is the electronic configuration? This is 1s2, neon 1s2, 2s2, 2p6. So in the valence shell it is having the 8 electrons. So how we can represent that? How we can represent the neon? So neon. So total how many electrons there is? 8 electrons is there. So this 8 electrons we can represent as, so 1, 2, 3, 4. Then pair of 5, 6, 7, 8. So you can see in the every direction, every side, it is a pair of electrons. In the every direction, it is a pair of electrons. So this type of configuration we can say as a stable electronic configuration. Stable electronic configuration means there is no single electron. All it is a pair of electrons. All the directions it is a pair of electrons. So if the electron is paired, it will not involve into the bond formation. So all the noble gases are the stable configurations. So by this statement, the chemical bond definition is changed. So all the atoms can try to the getting of a noble gas configuration or stable configuration. This can be changed as a octet configuration. 8 electrons, so octet configuration. So all the elements can try to get octet configuration or stable electronic configuration or noble gas configuration. Further, they will be involved into the bond formation. If the existence of 8 electrons, the atom will be stable. So it is inactive in the formation of the bond formations. Okay, so this is regarding Lewis dot structures. Next, electron theory of valence. It was proposed by Lewis and Coser. First, it is only Lewis is explained with the help of dot structures. But further, the next attempts by conducting some experiments, they are doing some attempts. They finally proposed a theoretical explanation of electron theory of valence. So, what is explanation here? In the year of 1916, the both scientists are given their independently definition. So what is that? It is a basis on only valence in the terms of electrons. Means if that atom having the valence electrons, based on that either it will be lose the electron or it will be gain the electron. Then it is having a net charge on that nucleus. So based on that it will involve into the bond formation. A theoretical explanation only there was given. Valence electrons, they are losing or gain. So how many electrons they can lose and how many electrons they can gain, and what is a stable configuration. So for that they given 8 electrons in that valency shell, then that atom is stable. Further they are checking of so many atoms. They concluded that if any atom having the 8 electrons in that valency shell, in the outermost shell it is occupied with the 8 electrons, that atom is stable, and it is highly stable, and it is rarely participated into the chemical changes. Means if the outermost shell filled with 8 electrons, it cannot be involved into the bond formation. Means it cannot further lose or further gain. So this rule can be stated as a octet rule. So what is the octet rule here? The atoms of the elements tend to undergo chemical changes that help to leave their atoms with 8 electrons in the outermost shell. So what is a simple definition? Every outermost shell of an atom, if it is filled with 8 electrons, that can be called as a octet rule. If it is fixed with 8 electrons, it is a highly stable. So check with the group of elements, because our periodic table having 18 groups. So all the 18 groups having 8 electrons? No. Every group having a different number of electrons. Further, they given some conclusion here. So first, second, third group. So first group, second group, and third group. So first A group elements having the net charge. So how can we identify that net charge? So take the example of sodium. Sodium having the configuration of 2, 8, 1. It is a configuration of 2, 8, 1. If it is lose the one electron, if it is lose the one electron, then it is stable to the 8 electrons. Means Na plus. Means its configuration is 2, 8. In the octet configuration in the valency shell, then we can say it is a stable element, stable ion. So the sodium can lose the one electron, then it will get the positive charge, and it is a stable configuration. Means first A group elements all can be attain the plus one charge. Okay, coming to the second A group, after the sodium, that is a magnesium. So its configuration is 2, 8, 2. If it is lose the 2 electrons, then it is attain the stability. So it will lose the 2 electrons, then it will attain the Mg plus 2 charge. So its configuration is 2, 8. Means all the second group elements will tend, that is the plus 2 charge. So third group. So in the third group it is aluminium. So 2, 8, 3 configuration. So if it is lose the 3 electrons, then it will attain the 2, 8 configuration with the Al plus 3. So it will attain the net charge is plus 3. Means first A, second A, third A, plus 1, plus 2, plus 3 on it's a net charge. Coming to the fifth, sixth, seventh. Fifth group, sixth group and seventh group. So fifth group means you can take the nitrogen. So its atomic number is 7. So its configuration is 2, 5. So 2, 5. So 5 electrons it is having. So when it is attain the stability, there is a 2 chances. If it is lose the 5 electrons, then it is attain the doublet configuration. If it is gain the 3 electrons, octet configuration near to the neon. There is a 2 chances. But losing of 5 electrons is difficult for the nitrogen. So that it will always try to the gain of the 3 electrons to attain the stability. So it will take the 3 electrons plus 3 electrons, it will get the nitrogen minus 3. So in the chemistry, gain of the electrons means negative charge, lose of electrons is positive charge. So N3, so its configuration is 2, 8. Means all the 50A group elements, all the 50A group elements will attain minus 3 on the net charge. Next, sixth group elements. Sixth group elements, oxygen atom, its atomic number is 8, configuration is 2, 6. So in the valency shell, it is having the 6 electrons. So to attain the octet configuration, so it is required the 2 electrons. It is required the 2 electrons. So oxygen will get minus 2 on the net charge. So 2, 8. For the 7th A group elements, the fluorine atomic number is 9, configuration is 2, 7. So 7 electrons already it is having. So it is required the 1 electron. It is required the 1 electron. So it will get the minus 1. So it is also configuration related to 2, 8. Means all the 7th A group elements having the minus 1 in the net charge. All the 6th A group elements can show the minus 2 as a net charge. So see here, from 1 to 3 is a plus 1, plus 2, plus 3. From 5th, 6th, 7, minus 3, minus 2, minus 1. Because by checking, sir, how should we identify this? So these 3 groups are present in the left side of the periodic table. Maximum it is related to metals. So all the metals can donate the electrons or lose the electrons or get the positive charge on the nucleus. All the non-metals, 5th, 6th, 7th group of elements are present in the right side of the periodic table, and it is nearly all the non-metals. So all the non-metals, it is having the more than 4 electrons in that valency shell. So it is required. It is required so that it will gain the electrons to get the negative charge on its nucleus. So this was completely explained by the Lewis and Kozel.